nearly at the end now with this introduction into matplotlib. So the last plot type that I'll introduce here, and this is not the last one there is, but this is the last one we cover today, it's boxplots. And they give you, in a way, they do something similar to the histogram. They give you an idea of the distribution of the data, but in a very different way. So they will show you the median, the maximum, the minimum, and the quartiles, and then you can also see the outliers. And often this is a great way of comparing distributions in different conditions and seeing whether there's change in the distribution introduced by treatments or things like that. Um, there are two ways again of doing it, and the matplotlib is it's great if you want to plot all the data. So for example, if you were interested what is the distribution of BRCA1 across all cancer types, we just get a single bar, a single a box plot, and that's easy and fine. But if you wanted to plot the distribution across the different cancer type, it gets quite complicated. So the code looks somewhat like this, and you need to have this patch method here, which is complicated. So I wouldn't recommend doing it this way. For this type of question, so comparing the distribution between breast and blood cancer, for example, it's much nicer to use the pandas API. So if you go df.boxplot, um, and then you say you want the column BRCA1 and you want to separate this by oncotree lineage, and that will give you a very nice box plot. Let's go straight to the notebook. And yeah, we imported matplotlib again as PLT, and we imported the data. So the first plot is just simply a box plot for matplotlib using BRCA1 data across the entire data for BRCA1, and that gives you a single pub. So this gives you shows you the distribution and the outliers. And now if we wanted to compare the different across cancer types, so we have this more complicated way of doing it. Oops, so I probably have to do this first and then run this. So that shows you comparing myeloid and breast. So it's actually higher expressed in myeloid cancer, but you get the same result. And I would stick for this type of question, I would stick with the pandas way of doing it. You say gndf.boxplot, and then you want to the column that you want to plot is BRCA1, and you get it's you know, it's much less code, and you don't have to worry about patch and things like that, and it gives you the same data. You can also separate the colors and think and make this look a lot nicer, but generally this would be the way I would recommend you to do this. So go through this notebook again. There's plenty more examples, plenty more to think about in box plots. But yeah, you've got a lot here to cover. I don't recommend you to do this all in one go, but I think you will get something out of it. Starting to play around and optimizing and really twiddling around with your presentation style figures and make this really nice is actually great fun. And having a large language model like ChatGPT or Gemini available to optimize this and really start going fancy with these methods is very useful. And they are very good at helping you with these things as well. So with this, we have covered most of what I wanted to say about matplotlib for today. So let's wrap up. We've done a lot of new content. We talked about vectorization, about group by, and then about EDA, and just EDA by just looking at the data with pandas functionality. And then most importantly, starting to visualize things using matplotlib and generating some really nice and informative graphs already, comparing our breast and myeloid data. And there's a lot more to do. So we just scratched the surface, but I would recommend you go through the exercises and also look at the data camp matplotlib introduction. That is very useful to reinforce a little bit what we learned here today. And in the next lecture, we're gonna take a step forward and actually ask some more statistical question of the data. And I will see you next Thursday.